Grade 8 and Grade 9 need to know about Ohm's law. In Grade 8, we really are just introducing the topic, and the CAP syllabus says that you need to do it qualitatively. Now, when I wrote that, it caused a lot of confusion. What does he mean? Qualitatively. Qualitatively means you're not taking any measurements, you are just getting an impression. In Grade 9, we will take measurements, but in Grade 8, we're just going to do it this way. What we're going to do is we want to see what is the effect on the brightness of the lamp if I add more cells to my battery. So let's start off with one cell, one lamp, and two wires. And I think you'll agree that that is a very simple circuit. And as you can see, the light bulb has come on. And if I tip it like that, perhaps you can see it even better. So one cell is making this light bulb glow very dimly. Now, Grade 8s, what do you predict will happen when we add an extra cell and make this a 2-cell series battery? Let's do that now. I loosen off the tension there, move the pen one space further down, put in another torch cell, move my connection further down, tighten this up, and come on, Grade 8s, let's have a prediction. Brighter, dimmer, or the same? What do you think? Is there no effect? Will it be brighter? Will it be dimmer? Well, let's look and see. I don't think there's any argument. That is definitely brighter than it was before. Start trying to think of why. That's important. I have a 2-cell series battery. It was a 1.5 volt cell. Now it's two 1.5 volt cells making a 3 volt battery. What do you predict will happen when I add the third cell and make it a 4.5 volts battery? Let's see.
We can draw some simple conclusions from this demonstration. Essentially, more volts will give you more amps, as long as you don't change the globe. A more scientific way of saying this is increasing the potential difference causes an increase in the current strength if the resistance stays the same. What did Ohm conclude from the full experiment, which we'll do later? The potential difference is directly proportional to the current strength if the resistance is constant. What does this mean? A direct proportion means that if you double the voltage, the current strength will also be doubled, as long as you keep the resistance the same. It also means that if you triple the voltage, you'll triple the current strength, and if you multiply the voltage by 10, you will multiply the current strength by 10, as long as you keep the resistance the same. That's what a direct proportion means. If one variable goes up, the other variable goes up by the same amount. On the other hand, an indirect proportion, or also called an inverse proportion, means if one variable goes up, getting bigger, the other variable goes down, getting smaller.